Hi everyone. I hope you all are doing great. Welcome to day 3 of Kubernetes real-time projects. In this project, what will be your learning along with the project? You will learn about concepts of environment variables in Kubernetes, secrets in Kubernetes, and services in Kubernetes. Now, let us begin. First thing, secrets. What is secrets? So secrets is designed to store sensitive information like password, API key, TLS certificates, and other confidential data. It is intended to keep sensitive data secure and separate from application code. So is a type of Kubernetes object which stores the sensitive information. Apart from that, you have environment variables. Environment variable is used to pass configuration data like sensitive or non-sensitive to application running in containers. Typically used for non-sensitive applications like feature flags, URL, environment specific settings. So it's a kind of configuration data which you pass to your running containers. It can be non-sensitive or sensitive, but it's like a configuration kind of information. Now, if we talk about security aspects between secrets and environment variables, secrets stored securely in Kubernetes etcd database and it's encrypted at rest. To access it is restricted using role-based access control and base 64 encoded by default, not encrypted, but it's really secure. Environment variables stored in plain text within the container runtime environment. So it's in a plain text. Less secure for sensitive data because they can be exposed through logs, debugging tools, or environment inspection commands. So you understood why secrets, not environment variables, in case of sensitive data. Now, these secrets can be mounted as volumes or environment variables. Secrets can be injected into pod as environment variables for easy access by applications or as a file mounted as volumes in the pod file system, or you can attach it, this secret, as a file. Take an example. So suppose in the environment variable you are telling DB name and value from secret key reference. Name is my secret and key is username, and then name is db password, value from again secret key reference, secret file, name is my secrets, and key is the password. And this is referring from secret key reference means secrets file. Similar way, if it is mounted as a volume, in that you can do volume mounts and then name is secret volume, mounting path where you are mounting etc secrets, and read only is only true, and volume is secret volume and secret is your secret name. So this way also you can do. Now you understood why secrets, why environment variables. Now the third concept which we have to learn today is services. Services is very important in Kubernetes world. So in Kubernetes, a service is an abstraction that defines a logical set of pod and policy for accessing them. It provides a stable endpoint IP address and DNS names for communicating with pods. Even as pods themselves are dynamically created, destroyed, and rescheduled, services enable decoupling between the front-end and back-end component of an application, ensuring reliable communications. Just take an example. So, suppose in our previous projects, we have deployed two pods of Flask applications. Like this was pod 1. So you have P1 and then you have P2. When I was exposing the applications, I exposed for one of the pods. So load balancing was not happening among them. So what we do, we create a service as a abstraction layer. And now what happens that once your pods are destroyed, and if you are exposing some port, obviously the pod name will change. So that exposing again you need to do. But if you create a service, you release the level of applications, and then that level is pointing to all the pods. Now this service will point on the particular pod port number, and suppose if pod 1 is deleted or pod 2 is deleted, new pods are coming like pod 1 and pod 2, no problem because it's using the level of these pods. So of course the service will again pointing to them, and it is kind of automatically do the load balancing. So it will distribute the traffic across the pods whenever application will you will hit on the particular service. So now you again reiterate, in Kubernetes, a service is an abstraction that defines a logical set of pod and policy for accessing them. It provides a stable endpoint like IP address and DNS names for communicating with pods. Even as pods themselves are dynamically created, destroyed, or rescheduled, services enable decoupling between the front end and back end components of an application, ensuring reliable communications. So, what are the features of services? Services provide a stable IP address and DNS name that other application can use to access the pod, even if pods are replaced or rescheduled. Load balancing. Services distribute traffic evenly across all pod that match the service selector. And I told you those level matching does. Service discovery. Service enable automatic discovery of pod using DNS or environment variables. Abstractions. Services abstract away the details of individual pod, allowing you to focus on logical grouping of pods. And it support for multiple protocol like TCP protocol, UDP protocol, SCTP protocol. Now, there are multiple types of services. Cluster IP. So, cluster IP is the default one. Exposes a service on a cluster internal IP address. So, see, Kubernetes is installed over Linux, and inside the Linux, each pod is assigned a separate IP address. Now, that IP address is different from the host IP address. So cluster IP service, if you create, that only allow you to access your applications within the pod network. So exposes the service to a cluster internal IP address only accessible within the cluster. Use cases internal communication between microservices. But suppose you want to access that application on the physical nodes using some load balancers or something. In that case, expose the service on a static port on each node IP address. So accessible from outside of the cluster using node IP colon node port. So what happens if I explain you in high level term, then what happens? See, so you have your service. This is your service. And these are your pod 1, pod 2. So this 2 is pointing to this service. Now, when you are exposing your service or running your service on suppose 8080, but this 8080 is only accessible within the cluster. But suppose this service is a load balancer, or you are attaching this service is running on a physical cluster, you are attaching a load balancer. Now if in the browser you will type the load balancer, of course load balancer is not part of the cluster, so it cannot access your 8080 port. So in this case what happens, we create a service and the type of service is called node port. Node port is like it does the mapping of 8080. 8080 port will be mapped to some higher port like a port number like 32001, like something like this. So when you will do the load balancer colon 32001, it will exactly point to 8080. 8080 will point to the pod port number, and then your application will be accessible to you. So this way it works. So node port, I hope you understood, exposes the service on a static port on each node's IP address, accessible from outside of the cluster using node port. Use case development or debugging, or when you need external access but don't have a load balancer. So one is obviously some public cloud provides a load balancer type of service, but in your private organizations, if this type of service you are not using, then of course node port you can use and then you can expose it. Another type of service is load balancer. This type of service like AWS EKS cluster or Azure Kubernetes cluster or Google Autopilot cluster, GKE clusters. These clusters nowadays provide a service type itself is load balancer. So when you define your service type as a load balancer, automatically it is exposing that particular port to the external or outside world. So these are the different type of services. Of course, we'll do a lot of things practically in this, but now let us move to our project. So in today's project, we have again a Python applications, and what this Python application is doing. So in Python applications, we are having a database and we are connecting to database using this Python Flask applications. So first, to connect to the Postgres database, we have psychopg2. This is a module to make the connectivity to database Postgres. OS module we are importing, and then we are importing Flask, request, and JSONify. Again, we are creating an instance. So here app is equal to Flask name, and then database URL we are getting using os.getEnvironment database URL we are passing. So now function, a function is to connect to DB. So how to connect to DB? This psychopg2.connect, and then database URL you will pass, and you are making a message print connection made, and then return the connections. Again, application root is the main root path slash, and then defining hello world, and it's returning hello world. Then again, application root if slash submit, and method is post method. Then what you are doing, request.json.get name, getting the name, getting the message, and then you are of course calling the connect method, connecting to database, and cursor is equal to connect.cursor. And after once this is done, you are just doing cursor.execute and insert into that particular table. So insert into public is the database name dot message table, and then here you are passing the name and value which you are getting as a input in the post method, and then committing it into the database, and then closing the connections. And then in the return you are doing JSONify, and status is message is stored successfully, and 201 else 201. If this is the main, this is telling that okay, this is not a module, this needs to be executed here. So app.run debug is true, and then again allowing all the hosts 0.0.0 and port 5000 we are running. So now I hope this code is quite clear. Now if you go, there is one component which I told, that is secrets we have to create, because to connect to database, obviously database username and password will be needed. So we have to create an object called DB secrets. So API version v1, kind is secret, name is DB credentials, type is opaque, and data, in the data you are passing the database URL. And this secret how we are getting, I'll explain you in few minutes. So database URL, how this value we got. Now, if you go Postgres deployment, first you need the database to be ready. So kind of deployment, metadata is PostgreSDB, one replica, match level is PostgreSDB, template is PostgreSDB, spec is PostgreSDB. This is the version of Postgres 1.3. Image pull policy, only pull if it's not present. Then environment, Postgres database. Value is DEVOPS. Postgres user is Postgres. Postgres password is password. And then it is running on port 5432. And now to connect to the Postgres database, we are creating a service. So kind is service. Name is PostgreSDB service. Selector is obviously PostgreSDB. And then port, it is 5432 because your this Postgres is running on 5432. So this service will connect to 5432 container port, and it is using a selector PostgreSDB. So suppose here you have multiple replica, no worries, because it's using matching the level, and then this is the app level, right? So whatever the pod will be there, they will have the same level here. So it will, service will do the load balancing across all the pods. Once we deploy the service, then what is there? Next is you need to create the deployment. So deployment, Python app, name is Python app, to replica, Python app, and then Flask 0.4. This image we can maybe make 0.6 while creating. Container port is 5000. Database URL. Here you see as an environment variable, we are telling database URL, and then where we are getting value from secret key response and key reference, and here name is DB credentials and key is database URL. If you go to the DB secrets, name is DB credentials. So in the environment we are telling name is this, and database URL, its value we are getting. So here if you see database URL, the key value we are getting here. Now if you have to deploy, so first What we have to do? We have to pull this Postgres 13 image in our system. So let us go there, clear the screen, and then pull this image. So image Postgres is pulled. If you do Docker images, you will see Postgres 13 is already here. Now you have to load this, right? So to load in your kind cluster, kind load again. So kind load, it will load to all the control plane and worker node. And once this is done, you have to create the Postgres database, right? So kubectl apply -f and then PostgreSDB deployment.yml file. So let the loading complete and then we'll do the deployments. We'll start doing deployments. So if now you see this is loading is done. So if you here see in the directory, you have PostgreSDB.deployment file. So kc kubectl means it's the alias apply -f and then Postgres deployment.yml. So your deployment and service file was also inside that. So it created deployment and service. If you see kc get pods, then you will see Postgres pod is already running now. If you see kc get sbc or kc get service, then you will see Postgres DB service is created and it's using 5432 port. Now, once this is done, then you have to go inside the pod. So how to do? kc execute -it. I is like as input and you are going to terminal and then copying this pod name. So pod name and then you have to do -bin sh. So I want to go inside the Postgres DB pod. So now if you click, so you see has means we came here. After that, you connect as a Postgres user. So su-postgres. So now I am inside this Postgres and to connect to the Postgres command prompt, psql is the command. So now you see we are inside Postgres. Now, if you want to see how many tables are there, so describe tables. So we are now inside this. Now suppose first we have to, because no tables were created, so we got the empty message. Now create table messages. So if you do create table message, id name and message, so create table is returned means it's created. Now let us try. So you see message table got created. Now you know database URL. So update database URL in application code to build the image. So this is the database URL. How to pass it? Postgres, Postgres, colon, and its password is this, and the service is Postgres DB service, colon, which port it is running? 5432/Postgres. So this is the database URL. Now, if you will do this database URL and you have to, before building the image, you have to pass this database URL and then you are doing the Docker build and we have made it as in the deployments. If you go, so Postgres deployment is done. If you go to the app deployment, here image tag we have given 0.6 and here we are passing the key as a database URL. So now what we have to do, we have to first build the image. So with this Docker file, you first you exit here, exit, and then here you see a Docker file is there. So cat Docker file, and if you say what we are doing here, Python, and then web app, and then installing this psychopg binary, numpy and panda, exposing 5000 applications, and here you are running the Python app.py, and then this will run. So just now do Docker build, but what you have to do, Flask app we have given the image tag as 0.6. So let us do the same, 0.6, and just type it here. So it has started building the image now. Image is getting built. So yeah, now you see downloading psycopy binary and those things. And then it is moving ahead, installing NumPy, Panda, those inside our Docker image. So it's taking some time to get it done, but yeah, just wait a minute, it will be done. Once this is done, of course, we have to load again. So for loading again, this is the image tag. So we have to load it now. Once this image building is taking time, so this Flask app we have to load inside our kind cluster. And after that, this echo we are doing Postgres password, Postgres DB service, and there we are decoding it. This complete URL, how we are decoding, I'll show you. It's taking time. Okay. So now our image build is done. If you do Docker images, you will see 0.6 is here 6 seconds ago. Now, what you have to do? You have to load this image into your kind cluster. So let us do the same. So to load it, just copy and then go here and load. So now it has started loading to our kind cluster. And after that, this is exactly doing? This is connecting to Postgres and then using this service, and whatever after the connecting, it is just getting the credential details. So create database URL as secrets. How we'll do? Let us see. Because this complete database URL we have specified, and in the URL what you have to give? Your database name, then database password, and then the service name because you have to connect to the database service, and then the port details. So now this whole thing we want to create as a secret, and this secret as a URL we are passing to our Python code. So now you can see our loading is done. Now what is next? So you have to get this, connect to it, and then get the encoded form. So if you see, I got this as a URL. So what we are doing exactly? We are just finding a way to connect to database, and then just we are making it base64 encoding. So this value we got, just take a note of this value and go to your secrets. And if you see here exactly, so same value which I got, I pasted here. So if you match CG9ZDXY, and in the last ZXM equal to ZXM equal to. So this proves that whole your database URL is getting converted into a secret. So now you understood this. So what is the next step then? The next step for us is apply the secret. So just do kc apply -f secrets db secret.yml. So your secret is created. How to get? Kc get secrets, and you will see db credential secret is already created. Now once this is done, you have to apply, create the deployment. So kc apply -f, and in the deployments already we changed the image to 0.6, right? And this file has been saved. So kc app hyphen deployment app hyphen deploy main.yml. So deployment is done. Now once your deployment is done, after that you have to create the service. So app service kc apply -f, and then app service.yml. So your service also got created. So if you get kc get po, then you will see Python app is deployed. And if you do kc get svc, your service is also done. So Python app service and Postgres DB service both are created. Now create the port forwarding, because you have to forward the port. Previously we used to do port forwarding for our port exactly, but now it's a load balancing, right? Because service is created, so you do the port forwarding for service. So port forwarding for service. So now you see this port forwarding is getting done. And after that, if you go to web browser, you should be able to visualize it. So if you see here, then localhost colon 5000. So see, your web browser is accessible. So port forwarding is working as expected. You again refresh the page and you will see handling connections again. So handling connections, refresh, you do multiple refresh of it, and you will see handling connections. So now it's able to connect. Now what's next? Suppose I want to access these applications using curl in the local system. And what I want to do, I want to submit a message inside the database with the applications interacting like DevOps, and messages take a stack, hello take a stack. So what we are doing, curl hyphen x post http, this is the localhost colon 5000 slash submit we are calling, and then as a header content type we are passing as application JSON, and then in the data name is DevOps and message is hello text DevOps text stack. So if you copy this and just close it now, because with the command prompt we have to submit the request. So if you do this, okay, so what message we got? It's telling could not connect to the server. Why it cannot? Because your port forwarding is not working, right? So if you want to do, we can do the port forwarding in the backend. To do it in the backend, maybe no hub, and then here put the and percent symbol, and now port forwarding is working. Let us try again, Carl. So you see message is stored successfully. How I can verify that? So to verify that, you have to connect to database. So do one thing, kc execute, go inside the database, and then su hyphen postgres, and then psql, and then slash dt, describe tables, and then select a star from messages was the table name and semicolon. So here you see hello DevOps, hello tech stack. If you want to try it again, let us give one more try. So this, and instead of hello tech stack, we are telling k8s test tech stack, and name is demo python. So message is stored successfully. Now go inside the pod and then again run su hyphen postgres, and then psql, and then select star from messages. So you see this is already published. So I hope you understood this completely, how to create a service, how to deploy a Python applications, how to connect to the Postgres database, how to create the two-tier applications, how to make the communications among them. I hope this concept is quite clear to you guys. Put us in the comment section if something is not clear to you.